Okay, so let's start all over again. My name is Godwin 𝐂𝐎𝐍𝐍𝐄𝐂𝐓, and today we are having an SQL class. We just going through the foundations of SQL at the moment. Just the basics that you need to know for today. We're not going to do much lifting today, just soft stuff. So we start with the first question I asked is what is SQL, and somebody rightly answered is structured query language. And I've also just said that it's a standardized programming language for managing and manipulating relational databases. So mind the words, for managing, manipulating relational databases. So there are three keywords there: managing, manipulating, relational data. The reason why I pause is because relational database is not actually always two words. Okay, so let me rather say a phrase, three phrases there: managing, manipulating, relational databases. So these are three key things that we need to look out for in the definition. So that brings us then to the next question. What is a relational database? For you to manage something and manipulate something, you need to know what it is. Now, we are here talking about relational databases. So what is a relational database? Who can tell us what that is?
I think it's a database that
Is
has
it still OM? Is that ON?
yes, still
Okay, let me ask somebody else.
okay.
I'm going to pick, if people don't answer, I'll just pick on them. I'll pick on them as I saw them when I called. So let me ask Osari. Oh, so we have the same Osabute, Osariemen. Okay. So when I call you Osa, just know that I'm also Osa. A lot of people call me Osa. It doesn't
Oh,
matter.
hi, that's nice.
Yes. So can you tell us what a
Sorry, what
relation?
was your question?
Pardon?
What was your question? Sorry.
Osa, don't make me angry with you.
Sorry. I
Okay.
almost fell asleep. I heard my name again.
My question is, what is a relational database?
As I said before, I haven't really attended this, so I wouldn't know.
Oh, I'm just picking your brains. I've just mentioned three keywords: manage, manipulate, relational database. Now, before we go into the management and manipulation side, I'm just asking the general question. Okay, who knows anything about who knows what a
I don't.
relational database is? I don't want UM to answer. He's answered one question already. So
Sorry, I
somebody.
don't know. But Owen, if you know it, can you tell us, please?
No. He's answered one question already. So I just want him to give the rest the opportunity. Okay, if no one would answer, let's OM try again. But you see, in a class, those who try to answer questions are actually the ones who get to really understand the subject. So don't shy away from answering questions. It's all part of practicing. Nobody is going to, there's no wrong or right answer. No, let me not say there's no wrong or right answer. There's no wrong answer. Nobody is going to crucify you if you give a wrong answer. It's worth trying, especially at this stage at which we are, you know. And when I say at this stage at which we are, I just mean that um, this is something that you really want to do, and you've come here to do it, so just put in all the best, yeah? Right, so, can you tell us again, can you just give us an idea of what you think that is?
Okay, I think it has to do with a database that has two or different items on it that relate to each other. For example, if you're looking at a database of, let's say, an e-commerce database, which might have names of their clients and then maybe others or names of products and the number of products in stock, is in which they use to monitor how they have stock and how the stock moves. Something like that.
Okay. So, I think your knowledge is far more than our own at this point. I think you've tried, but you went more than I expected. Um, okay, let me just bring it down. Look at this Excel sheet that I have here. Can you see the Excel sheet?
Yes.
Okay. Now, how are things arranged in this Excel sheet? Can anybody tell us?
Things are arranged in rows and columns.
Beauty, that's all. There is an order, a predefined order of arrangement, rows and columns. Rows and columns. That is what a relational database looks like. The items within the database are arranged in a predefined relationship, or what we called schema. Now, where the data is stored in rows and columns, the columns are also called fields, right? The columns are called fields. So if I start filling this place up, for example, um, and I say John, DOB 0205 2000. And what school did he go to? UCL, things like that. I have Henry 03 09 205. And I say this, he went to where? King's College. And I say Mary. Mary is 10 12 2004. And Mary was where? In Cambridge. Yep. This is a database. Simple. That's what a database is. This here is a database. Things are stored. It's actually a relational database. There are things stored within this table in rows and columns, rows and fields. Okay, we will learn more about the rows and the fields as we progress, but this should suffice for now. So moving on, then if there are relational databases, then there should also be non-relational databases, right? If there is something called a relational database, then there should be non-relational database, right? So what will a non-relational database be like? Can anybody guess?
I'll guess that the items would not have any relationships.
Okay, beautiful. That's as simple as that. Can you give me an example?
No example is coming to my head now.
No example is coming to your head. No problem. Any other person? Any other person? Any other person? Okay, let's say this conversation that we are having, this discussion, this class that we are having, and it's been recorded nicely and kindly by Owen. Am I pronouncing your name right?
OM.
OM.
Yes, please.
OM. Okay. How is it being stored? Who knows? How is it being stored?
It can be stored on the computer or in Women's Cloud.
Stored, but how? How? I'm not asking for the medium within which it's stored. How is it stored? Now, we've seen an example of a relational database where data is stored in rows and columns. So how do you think this discussion that we are having now is stored?
As a video file?
As a video file. I like your attempt, honestly. I really do like your attempt. And what is the video file like? The long and short of it all is that it has no relationship at all. The speech, the audio, the video that is produced is not stored in a predefined manner. Data is just stored in chunks as and when various bits of data can be gathered. But there is no predefined, you can't box the words that I say or your pictures into predefined rows and columns. You can't do that. So it's a non-relational data. The storage of this interaction is non-relational. And there are many examples like that. Right? There are many examples like that. Right? So we would see as we progress a few differences as we go on. So for relational databases, these would normally be manipulated by the program called SQL. Whilst non-relational databases are also referred to as NoSQL. So we also have NoSQL. An example of that is MongoDB. Right. Now, let's make progress. So I've just written something, DBMS. What is that? Let me just define that as we go. Database management system. A database management system. What is that supposed to do? Now, a database management system basically is any system that is used in managing the SQL language. You see, SQL is a language, but it cannot work. It cannot be used on its own. It's not a language like the speech we are having here, the discussion we are having here. No, it's a programming language. So it needs something within which it can how should I say it? Within which it can express itself, right? SQL needs a system or something. It needs a body within which it can express itself. And this system is what is called a database management system. Now, there are quite a number of them. And this is SQL Server SSMS, SQL Server Management Studio. We have DB2, Database 2. We have MySQL. We have PostgreSQL. Etc. These are just a few of them. Okay, recent one, we have BigQuery. That's a big one actually. Now, BigQuery is huge. BigQuery. Okay, so these are just a few of them that are there. The most common ones, though, are SSMS, MySQL, and then PostgreSQL. As a matter of fact, PostgreSQL is kind of overtaking MySQL because MySQL has got a lot of deficiencies. It's just been noticed that it has some, but still it is still very highly used in the market. It is still highly used, and it does most of the basic things that are needed to be done. But the boss of all of these is BigQuery. BigQuery, simply because BigQuery can, as the name implies, it is big, right? So whilst these other ones can only take a few gigabytes of data, BigQuery can take petabytes, which is really, really, really big. Really big. That's why I believe that is why it is called BigQuery. Nothing, I don't think it's because of any other reason. But I believe it's simply because of the volume of data capacity that it can accommodate. And I think that's why it's called BigQuery. Apart from that, it also has some visualization tools, which most of the other database management systems don't have. In fact, I don't know anyone yet that has a visualization tool, but BigQuery comes with a visualization tool of its own. Right. Now, SQL is a portable language. What do we mean by that? SQL is portable. Who can tell us what that means?
I think it means that you can work on it wherever you are, as in mobile, sort of, if you have access to the data.
So are you saying that, for example, if I have the data on the cloud, the data on my laptop, I can access it anytime?
Yes, once you have your laptop, if you have access, as in if you have access, I mean, is if you are allowed access to like have password to reaching where it is. For instance, if you can be in the UK and working on the same database that I will be in like Africa and say access the same database.
Interesting. Any contrary opinion? Who has a contrary opinion? I like us to knock heads together. It's always good to discuss, honestly. It's good to debate. It's good. It's really good to debate stuff. Any contrary opinion? Okay. I am tempted to disagree with you. In the sense that the specificity with which you mentioned the specific way with which you defined it is not quite correct. So when we say something is portable, you see that I've listed a number of database management systems, right? And also there is SQL, right? Now we are saying that SQL requires a database management system to express itself. It needs one within which to express itself. So it being portable means that the way it would work on SSMS.
From one system to another.
Pardon? Somebody was saying something?
Ability to move from one system to another.
Exactly. Exactly. That simply is what is meant by being portable. The ability of the language to be used across different systems. The language to be used across different systems. That is what makes it portable. So if you know if you've used SQL on SSMS, remember I said there are slight differences between SSMS and MySQL, right? So if you've used SQL on SSMS, you practically know how to use MySQL without even having used MySQL before. If you are suddenly presented with a MySQL database system, you would be able to operate perfectly in there. This only difference between these systems is that some of them have got slight syntax. There are slight syntax differences in the way the language is written, but nothing major. Remember when we started, I said that if you are able to use SQL in one, you like 95% will be able to use it across all others. Even 95% will be a bit too low. Let me rather say something like 98%. Right. There are slight syntax differences, just slight. And once you are able to learn these syntax differences, you pretty much know how to use the language across all database management systems. Right? But we are not going to go into using the language today at all. Let's just see the categories of the language. Categories. I think there are about 5 categories actually. Categories of the SQL language. 1. Who knows why I'm putting these dashes here? Who knows? Okay, let me not explain that. Let me. Oh, yeah, somebody was about to say something.
Are they tags?
Pardon?
Are they tags?
No, they are not tags. Data query language.
Is it the same like commands? When you say
Command.
when you say data query language, does it mean like command? Like
SQL, all SQL languages are commands.
okay.
The SQL is a command language. You tell the system what you want and it does it for you.
Okay, so is that the same thing as the query language?
Yeah, that's why it's called query.
Oh, okay. Okay.
That's where the word query comes from. So
Select.
pardon? Oh no, that's not it. We are not there yet. Easy, Tiger. Easy, okay?
Are they comments?
Pardon?
Comments.
Comments.
Yeah.
Yeah, go ahead.
Are they comments? The tags, the things you're putting there, is that SQL?
Oh, yes, they are comments. Yeah, they are comments. That's correct. Yeah, they are comments. So if I don't, you see this in itself, this thing here, this is a system. It's like it's a system that can take programming languages. So with all programming languages, if you don't want what you are writing to be part of the executable language, you comment them out. Okay. So we have data definition. First, I said data query, data definition. Definition language. So that would be what? That would be DDL. Then we have, and the third one is actually what we are interested in. Data manipulation language, DML. Manipulation. The third one is, this is what we will be concentrating on most of the time, but it's good for you to know what the other ones are. The fourth one is data control language. And then finally, we have transaction control language. Now, let's go back here. DQL. We say it's data query language. What do you think it will be used for?
To query the database.
Beautiful. That's the names. The name says it all. Used to query the database. And the key word for that is what? Select. The key query word is select. DDL, data definition. What do you think it is used for? The usage is in the name.
To define a database.
Defining and modifying data. Not the database, the data. Data is different from database, mind you. And the keywords here are keywords. Keywords are create, alter, and drop. Create, alter, and drop. And maybe I should just tell you right now so that you have it right at the top of your mind, even right from the onset. One word that you should never ever use except you have authorization. And even if you have authorization, make sure it is documented authorization. Is the word drop. Don't ever drop a database or a table. Don't ever. You drop a database and that is it. That database is gone forever and ever. You can never ever retrieve it. Next one is data manipulation language, DML. And that is what we would actually be looking at quite in detail. Now, this is used for managing data. And that is where, as data analysts, we are. We manage, we manipulate, we see what we can, how we can turn the data, that is manipulate, so that we can do what? Draw insights and inferences from the data. We can draw insights. That is what the work of a data analyst is. So this is going to be the main focus of our study, this third bit. So it's used for managing data within a schema. When I say schema, it simply means what? Within a relational database, okay? And the keywords here are what? Keywords here.
Delete.
Huh?
Delete.
The keywords here again are select, insert, update, and somebody said delete. Yep, I'll take that. Let me ask you here, what do you think is the difference between delete and drop? I said if you drop a database, you lose it completely. What about delete?
You're just removing a row or just some data from the database.
Oh.
Not
Have you done
dropping.
database before?
Very little.
Okay, I'm not surprised. Your answers are quite on point. Yeah, that's correct. Very, very correct, as a matter of fact. Now, DCL, data control language. What do you think this is used for? Data control language. The usage is in the name. Used for what?
Permissions.
Permissions. Beautiful. Access privilege. Used for access privileges. permissions, access privileges, which somebody rightly said is permissions. So when, for example, I believe most of us here are working, right? When, for example, in your place of work, you can access a certain amount of data and your manager can access more. What does that mean? It simply means that your manager has got a higher privilege, higher access privilege than you. Right? Your manager has been given access to more data than you have. That simply is what it means. Right. And the key words here are grant. And who can tell us what the other one is?
Revoke.
Revoke. Grant and revoke. Grant and revoke. Data control language. Sorry, transaction control language. What is it used for? Used in managing transactions. And what do we mean by transactions?
Would that be the exchange of information?
Okay. Is it just information?
Data?
Okay.
Or
So simply exchange of anything.
okay, yeah.
Right. An exchange is a transaction. So when somebody gives somebody gives, another takes, and maybe gives something back. So that's a transaction. And we see this a lot of it in the supermarket. Let me use that as an example. When you go to the shops and you buy something, you pick a few things that you want to buy and you get to the till. What do?
You pay.
Okay, you pay. So can you find a scientific or a technical term for that thing, that payment that you have just done? What have you actually done? Okay, let me rephrase. Let me rephrase. Assuming you've picked the things, you get to the till, but you don't pay, you just walk off. What will that be classed as?
Theft.
Theft. Beautiful, that's correct. But when you go and then you scan the items you have picked and then you pay, what have you actually done?
Transaction.
Okay, but what exactly have you done? Which part of the transaction have you done?
You fulfilled it.
You've exchanged your money for your goods.
I want one word.
One word.
Confirmed. You fulfilled it.
Shall I say execute?
No. Right. You have
Committed.
committed to owning those things. You have committed to owning whatever it is that you have taken. Right? So the word for confirming a transaction is to commit. Commit. So you've committed to owning the transaction. Now, assuming that after committing to the transaction, you get home and then you realize that one of the items is defective. So you bring it back to the shop and then you go to the customer service counter and you give the item to the customer service agent. They scan it back and then give you a receipt and then refund your money. What exactly? I just want one word. What exactly have they done?
They've reversed the transaction.
Okay, reverse the transaction. Beautiful, but I want another word. I want a programming word for that.
Rollback.
Rollback. Rollback. They've rolled back the transaction. Right? They've rolled back the transaction. Beautiful. So these are the 5 categories of SQL languages. Are we getting something?
Yes.
Okay. So like I said, this is just the beginning. Asheshebere. As we progress, it will become more interesting. It will become more interactive. My classes are usually very interactive. I like you to interact. I like you to come with your own laptop and try some of the things that we do. Let me ask you this question. Have you already set up your SQL Server Management Studio?
No.
No.
Oh,
Have you already had a class in Power BI?
No.
No. Okay. Okay. So maybe we would even set it up before Mr. Is it Mr. Emmanuel? I've forgotten the name of that guy who will take you in Power BI. I think it's Mr. Emmanuel.
Ebenezer.
Oh, yes, Mr. Ebenezer. Mr. Ebenezer. Yeah. Normally he starts his own lectures way before me, so he will set it up and give you a database. He will set it up with you and give you a database which you can use. But failing that, or giving that we have now started, I can just we may maybe next week set up our framework, and then I would give you a database, and then we can start using that. We can start using that to do our queries. Okay, let's make some progress. Let's make a little bit more progress and then we shall stop for the day, okay? Maybe like 15 more minutes and then we shall stop. So SQL is made up of what we call reserved words and user-defined words. Reserved words what do we mean by reserved words? What is a reserved word?
words we use for SQL only.
SQL only. Did you say SQL only?
Yeah.
All right. So if you say select, is it used for SQL only?
Databases only, or database query only.
Okay. So reserved words basically are a fixed part of the SQL language. They are fixed in the way they are written. They are fixed in their meaning. They must be spelled exactly as required and cannot be split across lines. They are fixed words. They don't change. They are kind of like the building blocks. So for example, if you want to put up a building, what do you first do? You lay the foundation and put up the pillars, right? These pillars don't shift. You can't change their position. If you change the position of the pillar, you might as well change your whole architectural design, right? So the reserved words operate in similar manner. They are a fixed part of the SQL language. They are fixed in their meaning. They are fixed in the way they are spelled. If you spell them wrongly, your query would not run. Your query would not execute. An error would be thrown, right? So you must get your reserved words on point. So all these words that we have mentioned here, for example, earlier on, all these keywords are reserved words. And there are many more. Okay, all these ones are reserved words. Okay? User-defined words. What are these? User-defined words. What does that mean? User-defined.
Words we've made up.
Yeah,
for
words that the user themselves have made up. The words that the user themselves have made up. For example, I just drew up a table here, and I just called this name. I just called this DOB. Mind you, DOB here, I could have written it as what? Date of birth. But I decided to write DOB, which, as you know, means the same thing. But DOB could mean something else to somebody else. Right? I have written school here. Somebody could have written institution. Somebody could have written college. Somebody could have written university. You understand? So these are user-defined words. Now, with user-defined words, it doesn't matter how you write them. You have chosen to write words, or you have chosen to use certain words, and you can write user-defined words however you like. The only thing is that once you have used a user-defined word, for example, I use school. When I am calling this word back in my query, I must call it the same way it is written, in the way I have written it wherever it is that I defined it. So if I have written school here, I can't go and call it as schools. It would fail. I can't do this. This would fail. Do you get that? It would fail. So user-defined words can be written however you like, but calling them must maintain consistency. The way you call them must be exactly as you have written them. Otherwise, you won't be able to call them. I believe when I say call them, everybody understands what I mean. Do we get what I'm trying to say?
Yes.
Let me see. Let me call someone. Let me see, make sure people are not asleep. Lovette, are you still with us?
I'm here.
Ijeoma. Ijeoma, Catherine.
Been answering. I'm here.
Emilia. I want to know those who are asleep. Lanre.
Yeah, Larry's
Wayne.
here.
Wayne.
I got you.
Augusta. I just want to know those who are asleep, actually. SQL, I tell you, is quite an interesting, it's interesting. If you, SQL alone can take you places. So it's something, if you want to do, just give it your all. Just give it your all. Right. So like I just said, user-defined words are words introduced by the user, and they can represent various database objects and relations. They can be used in many different ways, shapes, and forms. They are not restricted by any rules except what I have just told you, consistency. Okay? Now, the SQL language is also case insensitive. Case insensitive. What does that mean? Sorry, I have some dogs at home, so case insensitive.
Uppercase, lowercase, no problem.
Yep, uppercase, lowercase, no problem. Now what this means is that I can write select like this. I can write select like this. It is the same as select. Uppercase, lowercase, no problem at all. Because of this, we usually say that the SQL language is a free format language. It's free format, right? It's one of the easiest languages actually to learn. One of the easiest computing languages to learn. It's one of the easiest to learn, and it's free format. It has very few restrictions. Okay, very few restrictions. One moment, please. One moment, please. Jedidiah, I'm in a lecture, please. I am in a lecture, please. Hello. How are you? I'm good. Hello. Sorry. Yeah. Good. Right. So I was just saying that the SQL language is a free format language. Let me share my screen. Am I still sharing my screen? Yes, I think I am. I got right. We will just go through this, a few things left, and then we would stop. Okay. It's free format, however, it needs to follow a specific rule. So let's say it's free format, right? Free format. But must follow. Must follow these rules. 1. Each clause in the statement should begin on a new line. Each clause should begin on a new line. The beginning of each clause should line up with the beginning of other clauses. Beginning. Am I writing it correctly? Did I spell it right? Is it double N? Is it double N here? Or one N? I don't remember. I think it's double N here. Beginning of each clause.
Double N, yeah.
Should line up And the reason for this is simple. If they don't line up, they could be meaning something else. Once they don't fall in line, they either become a subset or superset of another clause. And the third one, that should be the last one. If there are several clauses, or if a clause has several parts, they should all appear on a separate line and be indented under the start of the clause to show a relationship. I would, okay, so for example, let me do this. Let me do this. Let's assume that I want this. So this clause here is one clause, right? What I have just done here, I'm saying that this here is a subset of that. So this is part of this clause. This here is part of this clause, is a subset of it. Are you getting me? But if I bring it here, just like I wrote it the first time, then this is right underneath, and underneath that one. They are different clauses. They are different clauses, okay? That is what it means. Now, so if a clause has several parts, they should each appear on a separate line and be indented under the start of the clause. That's what I've just shown you, okay? Clauses with several parts. I think we will stop here, okay? Besides, I have some strange visitors. I'll send you the notes. Who should I send the notes to so you can post? I'm not yet on your group, so I can't post onto your group directly. Has a group been created for you?
Yes, I think you've been added to that group.
Have I?
Yes, you have been.
When was I added?
This night.
Ah, okay. So if a clause has several, they should each appear on a separate line and be indented. So from next week, we shall really start doing some work. Indented. Okay, so that is our SQL beginning in short. That's the beginning in short. Okay. Next week we haven't really finished this part, but I think time is a bit gone. We will try to see. Or do you want us to go on? It's your choice. Do you want us to go on a bit more? Uwan.
It's gone past 11, I think.
No, please, can we go sleep? Thank you.
Oh, thank you very much. Thank you very much. Okay, cool. Thank you very much. So let's bring this class to an end, and I shall see you next week, Friday at 9 o'clock.